When I started this project over a year ago, I imagined a graceful automaton, an archer drawing and shooting 3 arrows. Ambitious but achievable. What I didn't expect were the hidden complexities waiting inside this mechanism. The early attempts were rough, the arms moved but never with the precision the design needed. Eventually I hit a wall and I stepped away to clear my head. When I returned, I realised the real issue wasn't the cams or the joints, it was the cable system. Each joint relied on paired tension cables running through tiny guides to 18 cams. In theory, independent. In practice, they were constantly fighting each other. So I went back to the drawing board. Early in the concept stage, I considered hydraulics, an idea I dismissed almost immediately. Tiny linear and rotary actuators, miniature O-rings, silicon hose. It sounded ridiculous, but also possible. To satisfy my curiosity, I built a prototype. I even put the whole assembly in a vacuum chamber to purge every last bubble of air. And when I tested it, it failed spectacularly. It became clear that this wasn't the answer. Another dead end. At that point, I had one final idea left. If this didn't work, the Archer was finished. The plan was to house the control cables inside sleeves, essentially miniature Bowden cables, but at a scale that felt almost absurd. I needed something no more than 1.5mm in diameter with a 0.6mm internal bore and long enough to reach the furthest joint. I searched everywhere. Nothing. I contacted manufacturers, all declined. I even tried stripping the core from guitar strings, but the outer winding refused to come off cleanly, which left me with one option: make the springs myself. It's future Oliver here. I'm just going to pause the story for a moment. After finally managing to make several long lengths of this spring, I thought it'd be really interesting to show you how I've manufactured it. Now, I've made plenty of ordinary springs and they're really easy, but making something this small, this long and still of good quality, I honestly thought it would be almost impossible. Turns out they're actually very straightforward. So let me show you how I've done it. I'm using a lathe here, but if you only need short lengths, you could do the same thing with a cordless drill. The wire I'm using is 0.3mm phosphor bronze. It's flexible, it's a bit more delicate than stainless or piano wire, but once it's formed into a spring, it toughens up nicely. To make the longer springs, I made this tiny collet. It's the same diameter as the finished spring, and it lets me feed the spring back through the chuck bore. I'm starting with a 0.6mm stainless steel mandrel. I wrap the phosphorus bronze around it a few times so it grips and supports the collet. Then I trim off the straight end so it can pass through the collet when needed. After that, it goes into the chuck and I tighten it gently. Now let's look at the tailstock setup. Because that's what supports the mandrel, I've machined a nylon cap with a hole in the centre, and that sits on the end of the brass tube. The tube slides over the brass rod fixed into the tailstock. Then I slide the mandrel into the nylon cap and use the tool post for a bit of extra support. Before I start, I reverse the lathe and I drop the speed right down. I'm holding the wire lightly under tension with a pair of plastic insert pliers, and then I switch it on. The trick is to keep the wire just slightly behind the forming point. Once it starts, you can increase the speed a little. Now, I've only been brave enough to take these to about 120mm so far. If you want to go longer, you just need to form the spring back through the collet. It will unwind slightly as you release the pressure from the chuck. So hold the other end of the spring as you push it through. Then you tighten it up again and repeat the process for as long as you need. I genuinely thought I couldn't do this. I thought it would buckle, twist or snap under pressure, and I think that's a big win. I then cut a small section of the spring, threaded a scrap cable through it and tested the friction. I expected resistance, maybe even total failure. Instead, the movement was smooth, controlled, consistent. For the first time in months, I felt real hope. Better still, the system could be integrated into the Archer without a major redesign. I added fixtures throughout the body, anchored the sleeves and connected the right arm to the cams. And then it worked. The motion was smooth even under high tension. The extreme movements that once caused chaos now flowed with a kind of expressive grace. Those exaggerated cam profiles, once a desperate workaround, suddenly produced beautiful fluid gestures. It felt like the Archer was finally waking up. Because of the new cable system, some of the functions on the original cam follower had become obsolete. So I redesigned the entire tensioning setup to make it more reliable and far easier to adjust. Previously, I had to tension the cables by hand, a fiddly, inconsistent process that made it almost impossible to get everything equally tight. To fix that, I removed the old parts and built a new housing with a worm gear and a small cog, which now lets me tighten each cable mechanically. I cut the cog using a threaded tap, something I'd never tried before, and to my surprise it worked beautifully. The whole mechanism functions a bit like a guitar tuner, smooth, precise and incredibly satisfying to use. That breakthrough resolved so many issues, which was a huge win, but it still isn't hitting its positions consistently. I'm increasingly convinced the problem now lies in the cable itself. I still want to experiment with different types to see what suits this system best. But ultimately, I think I need to stop trying to force the cable to behave the way I want and start working with the way it naturally behaves. Maybe I'm asking too much of it. Maybe I need to accept a degree of inaccuracy. I did, after all, allow for those tolerances right at the beginning of the design process, especially in the draw hand, which has a generous scope for picking up and loading the arrow at critical moments. The Archer is finally starting to move forward, and I'm increasingly confident he'll get there. At this stage, I'm really just pushing for the last degree of reliability, the part that turns working mechanisms into a trustworthy one. I'll keep documenting the build as it evolves. Thank you so much for watching, and I'll see you in the next video.